I will now rerun the analysis using a different mesh type and different mesh density. And to do this, I will right click on this study name and I will say copy the study. This will save us a lot of time because then we do not have to change any other thing and we just directly will change the mesh options. So, from the source it is the same source the study that I used. I will change the name here and I will call it as chorus mesh, but in I will say high quality. So, basically this will be high quality, but the size will be chorus. Okay. So, I will say chorus size. Okay. So, high quality chorus size, and I will use all the other features same as previously. So, I will not make any other changes and I will just say OK. So, now automatically the software still has the same fixed conditions, same force and everything. It even has copied the results file, but these are right now meaningless for us because these will still be the old results. So, to get the new results, we will go on to the mesh tab, and in the mesh tab we will say create mesh again, and it will give us a warning. It will say that, oh, if you do this, your results file will become invalid, but we do not care because we will recompute the results. Okay. So, we will say yes, no problem, let us do that. And this time I will, when I come here in the controllers, I will actually move this slider all the way back. So, now I actually have much bigger elements. Each element is around 8.5 mm in terms of its base length, and I will actually use that. But another key difference here is that I am not only changing the element size, I am also changing the quality, which means that I am introducing more nodes in the middle of the element as well as in between the boundaries. Okay. So, previously it was a low quality mesh, now draft quality mesh. So, now I will move it to high quality. So, I will move this now to the top portion with the high quality. Now, when I do that and I save, click OK, now you can see the software has recalculated my mesh for me, and this time the mesh has much bigger looking elements, but the elements are higher quality, meaning that previously you only had nodes here, here and here, right? But now you have nodes somewhere here, some of them are here, some of them are here. So, you have actually got increased the number of calculation points. How we can check that? We can check that again by right clicking on the mesh and going into details option, and just like in the previous case, I noted down the number of nodes and elements. You can again note down the number of nodes and elements, and this time you understand that because of the large size, the number of elements is actually less. So, the number of elements is 1027, but the number of nodes is actually bigger than the previous case, which is 1902. Okay. So, now the number of elements and nodes is more, meaning that it will be requiring to solve those equations f is equal to ku based for all of these 1902 nodes. So, we expect the results to change, but because this number is not hugely different, I will expect the results to remain close, not very, very different, but we will see the effect. Let us see the effect. So, to do this, we again have to run this study, right. So, once we run this study, the software approximately takes the same time as previously and again shows us the values. But this time immediately you can see that the maximum stress is now 159 and the minimum is -16. So, I will quickly note down these numbers. So, 159.14 and -16.16. So, you can see the max and the min have changed. Let us see if the average has changed or not. We will go to the probe tool. We click anywhere away from the from the actual point, and we see that it is around 55.03. So this average has not changed significantly. So this average is still very close to that, so 55.03. And then if we go back and we actually compare the results of the displacement along the x-axis, we note that the displacement is also not changed significantly. It has changed, so it is now 4.804. So let's write down the new number. So it is increased slightly, 4.804 e minus 2, right? But it has not changed drastically. So because the hand calculation results are of course still the same, so I will just simply copy these over, and right. So you can now see the new percentage of error in terms of the displacement has increased slightly, okay, but the error in case of the maximum stress based on our stress concentration factor approach has actually reduced significantly. So for many actual applications, this level of accuracy will be sufficient because you will be still keeping some factor of safety in the design, right? So this level of accuracy may actually be acceptable. Think about this from the point of view of very large parts, where having lower number of elements is good for your calculation, because then the software can actually compute it. Let's now move on to the next analysis with the default size and high quality. Okay. So I move on to the next one. I will discuss the things in a bit more detail later. You can see also the y stresses and z stresses have changed, but because I've not noted down these numbers, so I'm not discussing them in detail, but you can clearly see that the max has shifted upwards for y and z as well. Let's now copy the analysis again one more time and rerun the analysis for and this time I will call it as, it's still high quality, but now I will use the default size, which is in the middle, right? Default size. Keep all the other quantities same. Again go back, making sure that all the other quantities are same. Going into the mesh, then creating the mesh again rewriting the old results, okay, and this time setting our pointer to default, which is in the middle, right, by clicking reset, and you can see that moves this number to 4.27. Now I will just, in terms of mesh quality, I don't have to do anything because it is still a high quality mesh. So all I have done is change the mesh size to the default value. I'll just say okay, save it, and you can see now the mesh, physically the mesh looks very much same as the one that we run in the first case, but actually it is different because the quality is high. So you can verify that by going on to the mesh tool, clicking on the details, and you can see here there is a huge difference between this and the previous case. So the total number of elements is still the same, it's 6,444, which is exactly same as our first case, but the node numbers, they have changed, they have become almost 10 times more. So this is now 10,627, okay. So that's a huge improvement in terms of nodes. So 10,627, and that will allow the software to be much more accurate in its calculation, because now it will be solving 10,627 equations simultaneously to get the results. So we will rerun the study by clicking on the run this study. Did you notice something? This time it actually took slightly more time. So there was a bit of increase. With these powerful computers on small parts, the increase may not be very appreciable. But think about doing a whole aircraft wing. Even this small increase in each part's time will lead to hours of difference in other parts. But let's now see the actual effect in change of stresses. And this time actually we have got some interesting results, because our highest results that we are seeing, not only the area that was shown as red has reduced, it is also now showing a value of 169.6, which is very, very close to our hand calculated results based on stress concentration factor approach. Keep this in mind, we have already tried to make our hand calculated results correct by using the published stress concentration factors. Otherwise, our hand calculation results would have just given us the net stress value, which clearly is way away from the actual values. So, we have got 169.01. So, this is our 169.60. Okay. So, that is our max stress. Our minimum stress is minus 16.72. So, there is very little change in that. And then our gross stress will increase slightly, but let us see what that number is by going into the probe tool. Okay. I'll use the probe tool. Right. So, we have got 55.01 again as the value. So, you can see there is hardly any change in your gross stress. The displacement values you can again compare going into the x displacement, and now the maximum is increased slightly. So, it is 4.812. So, it is 4.812 e raised to power minus 2, which is of course different from previous case, but it is not hugely different, it is quite close. So, when I now again calculate my error percentages, I can see that the error in the maximum stress has actually reduced to 0.18. The apparent error in the displacement is now almost 2%. But should I be worried about this or not? Not really, because if the stresses are being calculated more accurately, then I know that I took a big assumption in my hand calculation, right? I was basing them purely based on that 82 megapascal net stress and the gross stress of 55, right? So, though I knew that those were approximate anyways, right? So, these values, if anything, will be more accurate, not less accurate. So, this is not really an error in my FEA, this is more reflecting the error in my hand calculation, okay? So, that is why I will not be worried about it, and I can now actually, for most practical cases, this will be enough for your case. But there are cases when you need even more accuracy and you want to actually check if the values have become stable or not, okay? So, how can we do that? We can go to the highest mesh density that we can have on SolidWorks. By the way, this is just a limitation of SolidWorks, okay? In other softwares, you can maybe even go higher, okay? So, in the terms of SolidWorks, we will now go for a fine mesh. Before I do that, let me quickly save the analysis. Let me rerun the recording as well, because the recording file is becoming very long.